So hello and welcome everyone to the first ever Nomad Community Call. My name is Mishra. I'm a developer advocate at HashiCorp. I should actually turn on my video so you all can see me. 1 second. Hi. So this is the first time HashiCorp's ever done a community call. So this is fairly new to us. This is our attempt to kind of engage with our Nomad community. So I'll give a bit of a background on why we're even doing this, right? So this was brought up multiple times in our Nomad, like internal team meetings. And then also in the community, a bunch of folks have reached out saying we should do a community call. So this is it. So we're going to start this and we'll see how this goes. So the primary goal of the call is to get folks that are using Nomad or are curious about Nomad a platform to share their experiences. So this is very much a community-driven initiative. Hopefully it becomes like that. Right now, we did do some prep work for the first call, but the idea is to kind of open it up to the community and let them do demos and discussions and ask questions. So it is very much for the community. Another important thing for folks that are on the call would be that the HashiCorp Nomad core team is participating in the call as well. So they can directly answer your questions and they will be showcasing some of the Nomad features for this call. We also will have folks that are using Nomad in production in the future, and they'll kind of showcase how they use it and the implementation details and things like that. Since this was the first time we were doing this call, so we thought it was a good idea to have kind of like an agenda for this call. So the agenda today is, I'll do some introductions, and then the Nomad core team will take over, and they'll showcase do some intros to Nomad and showcase things like I'll be louder. Hold on a second. Let me bring the mic closer. There you go. Yeah, we'll showcase things like system and service jobs, and talk about ways to kind of ingress traffic into Nomad, and then talk about deployments and things like that too. And then we have guest presenters as well. So folks from SAP Ariba are here as well. They'll be talking about how they use Nomad in production. And then the most interesting part of the discussion is the open Q&A session. I'll try to moderate it, and then we can kind of go through the questions. You can add them in the working document. So a few of the announcements I want to kind of make some housekeeping stuff. So there is a working document that's linked to the invite and things like that. So you can kind of open that working document. There is an open Q&A and discussion section. You can keep adding your questions there, or you can paste your questions in the chat when we have the Q&A session. And then I can go through them. And then folks that want to speak up, we can just take the questions on the call as well. I think that was it. Yeah, so the meeting is also recorded. So we'll make the recording available in like 2 to 3 days after post-processing. And then, yeah, please do mute your microphones because, folks are presenting. Hopefully it doesn't get too noisy. So let me introduce our Nomad team. So we have two members that will be presenting. So our Nomad team lead, Alex Stadker, he's presenting along with Preetha, who's a Nomad backend engineer. And then the rest of the Nomad team is here too. So there's Michael, who's the front-end engineer, and he's worked on the Nomad UI that you see. It's super nice and good looking. And then there's Chelsea, Chelsea, Nick, and Chelsea and Nick, they're basically another set of backend engineers. And then we have Kate, who's an engineering manager, and then Rob, who's a product manager. So pretty much everyone's on the call. And also, I hope this is a good opportunity to kind of put faces to names that you see in mailing lists and issues. So now you know there are real people working behind this project. So yeah, okay. So take it away, Alex, before I just take too much of the time. We have very limited time today. So I'll make you the presenter. Let me quickly switch this. Okay. And I'll stop sharing.
Sweet. I'll share my screen. Thanks for that intro, Mishra. Yeah, so we're all very excited for our first community call. Thanks everyone for joining. So since this is our first community call and there's a broad audience here, I thought I'd briefly go over what a cluster orchestrator is for the people who don't know. A cluster orchestrator's role is essentially to take a set of jobs. These might be batch jobs, service jobs, and then map them onto a set of nodes. These nodes all might be various sizes, so it's the job of the cluster scheduler to pick the best match and keep it running. By keep it running, I mean these nodes might be ephemeral. They might come and go. They might be spot instances. They might fail, etc. So a cluster orchestrator's duty is to constantly be reconciling user intent with the state of the world. And so some of the benefits you get from using a cluster orchestrator are, well, they're different for developers, operators, and the business. For developers, you get a common workflow for applications. That really comes from the fact that the orchestrator insulates developers from the underlying infrastructure. That really gives developers a higher velocity since they don't need to go ask procurement for some VMs anymore when they want to deploy. They just write the same job spec they're used to and they're off to the races. For developers, they also get faster and safer deployments because cluster orchestrators often provide higher level mechanisms for rolling out updates in a safe way so you don't accidentally take out some production workloads. And they're resilient to ephemeral failures. You don't have to worry as much about your node failing or the disk getting filled up because the cluster orchestrator will detect it, reschedule your workload onto a healthy node, etc. For operators, there's also a huge set of benefits. By transitioning from this model where an application, there's a one-to-one mapping between applications and machine images in VMs. Instead, now you have one or two base images to maintain. And that makes it a lot easier to keep those secure, monitored, and up to date. And for the business, you really get a lot higher density, which means you can run less machines in your fleet. So that's generally the benefits you get from all cluster schedulers. So why Nomad in particular? Well, when we set out to build Nomad, we had some core tenets we wanted to maintain throughout the lifecycle of Nomad. We always want it to be easy for developers. We want it to be workload agnostic because technology comes and goes and your cluster orchestrator is a key part of your infrastructure. So you shouldn't have to retool everything when one technology changes. We want it to be operationally simple. It's important for operators to be able to understand what they're deploying, be able to monitor it, and keep it up to date. And lastly, we wanted to make sure Nomad could essentially scale to any size business. We didn't want it just to be for small deploys. It should never be the bottleneck of your deployments. And so I'm only going to talk about operationally simple and built for scale right now because Preetha will demo some of the features of the job spec and show off some different workloads. So why is Nomad operationally simple? Well, Nomad's a single binary that you can deploy both in server and client mode. And that's the only moving piece. You don't actually need to launch 5 different services, an external key value store to have Nomad up and running. And beyond that, Nomad's architecture makes it quite simple to deploy. The servers form a quorum with each other and self-elect leaders. All the servers and clients can do RPC forwarding, so you can point your clients at any agent and they can service your reads and writes. We also have a bunch of features that make bootstrapping clusters easy. For several releases now, we've been able to bootstrap clusters using console. If the clients and servers detect console in the environment, they'll register themselves and look for other registered Nomad servers and form a cluster. And a cool feature that's coming in 0.8.4, the next release, is we're integrating a library HashiCorp has made called Go Discover. It lets you do this same bootstrapping using cloud provider metadata. So you'll be able to specify some metadata such as tags on an ASG, and then all the servers and clients can query that metadata and discover each other. So it makes bootstrapping easy as well, even if you're not running console. So that's why Nomad's pretty operationally simple. Built for scale, well, when we set out to build Nomad, we've had already released console, and console has been deployed at pretty large scales, tens of thousands of nodes. And so we looked inward and we used the proven design patterns of console and reused many of its libraries, such as our Raft implementation and Surf. So we already had a lead based on the previous experience with console. And then we looked out into the scheduler space in academia, and we really touched on Google's own research with Borg and Omega, and the AMP lab at Berkeley for their Sparrow and Mesos papers. And the results were great. Last year, we benchmarked Nomad. We did the Million Container Challenge, which was a fun exercise. What we did is we brought up 5,000 hosts on GCE, and then we submitted 1,000 jobs with 1,000 tasks in them. So that adds up to 1 million containers. And we wanted to see how fast Nomad could schedule these, if at all. And what we found is we could actually schedule 1 million containers in less than 5 minutes, which was super awesome. And when we released this, there was some naysaying, like, what's the point? It doesn't really matter. Well, we found that with our customers and users, it actually did unlock a lot of use cases for them. Citadel, for example, did a benchmark of their own, and they actually blew our C1M out of the water. They ran 18,000 cores, and for a sustained 5 hours, kept scheduling against Nomad. And the average over those 5 hours was 2,200 containers a second, which is really, really awesome, and allows Citadel to do some very interesting things using Nomad. And recently, Circle CI just did a talk, which was really awesome, by Danielle Tomlinson. I've linked her YouTube video down there, but essentially Circle CI uses Nomad to schedule user build tasks, and they are now doing roughly 7 million builds a month, and they're sustaining 400 to 1,000 jobs a minute using Nomad. So it really has unlocked a lot of very interesting use cases. So that's some of the reasons to use Nomad. We think we've stuck with those 4 tenets since 0.1 to now, and we hope we can maintain that ease of use for developers and operators moving forward. But now I'd like to describe the demo we'll be doing for you all. What we're going to be doing is we're going to deploy a HA web service onto Nomad, and we want it to be load balanced so that as traffic comes in from the public internet, it'll hit a load balancer and spread the load across our HA web service. And then we'll show off how we can use Nomad's deployment features to actually update our web services with no downtime and safety. So what we'll see in this demo is the fact that Nomad has multiple scheduler types. It has service scheduler, which is for obviously launching services. It has a batch scheduler, which has certain optimizations for scheduling batch jobs with higher throughput. And it has a system scheduler for placing tasks onto all eligible nodes onto the cluster. We'll also see how Nomad can support multiple drivers. It isn't a single driver. It can do more than just Docker, for example. And we'll also see Nomad's integration with console to automatically do service registration and health check-ins, health checks. And lastly, how we can use deployment strategies to update the Nomad jobs. So this is a brief overview of what we'll be doing. We'll have an ELB that will point to the Nomad clients that we will then be running Fabio on. Fabio is a application load balancer that automatically integrates with console. It's a really cool project. If you guys haven't heard of it, I suggest checking it out. And lastly, the Fabios will be load balancing across the web services. And just for a little background, we've already set up the ELB and brought up Nomad. We just use the Terraform and the Nomad repo itself, so it's nothing special. So I'll hand it over to Preetha to demo, actually. So, stop my share. And then,
all right. Can everybody hear me okay? All right. I hope you can all hear me. Somebody say yes in the chat. Yeah. Okay.
Yes.
All right. Thanks, Charlie. Let me go ahead and share my screen.
I just made you the host.
All right, cool. So like Alex mentioned, we've already brought up a Nomad cluster on AWS. And I've pointed my the Nomad ADDR environment variable over here to the public IP of one of the servers. And this just shows you a couple of simple CLI commands. Just look at the cluster overall. It's a pretty small cluster just for demo purposes. We have 3 servers and 4 client nodes. So, and we'll go ahead and paste the IP address of or the address of our ELB. This is not going to work right now because nothing's deployed yet, but just have it on Zoom. So as I deploy, you'll be able to see this. So I'm putting this in the Zoom chat. Sorry for the horrible looking ELB URL, but I didn't want to pay for a domain just for this talk, right? But anyway, so the first thing that we need to do is deploy our load balancer. So we're going to look at a Nomad job spec. So we're deploying Fabio, which, like Alex mentioned, has some good first-class integration with console, which is going to act as our service registry. So the job type here says system job. So this means that this is a job that will run on every node, every client node in your cluster. So it's used in general for like kind of basic system level services that you want running on every node. This one is using the Docker driver. Again, like Alex mentioned, the driver itself is pluggable. So in this case, we have a nice Docker image already for Fabio available in the public registry. So we're going to use that. But the driver can be Rocket or a QEMU or even just a binary. And then here's the resource stanza. We have some basic resource limitations. And then in this particular case, because the load balancer is a relatively static part of our infrastructure, we're not doing dynamic ports. Like we're just specifying that we want the load balancer running on 9999. So that way my ELB is already configured to point to like 9999 across all of my fleet. So that's about it for the job spec really. So to go ahead and deploy this, we can use the run command. So I just say nomad run fabio.nomad. And then we can actually invoke the UI from the Nomad CLI. So if I do Nomad UI Fabio, and then tab on over to my UI here. So here, this is the Nomad UI on the left. And we can see that Fabio is running. And it shows that there are 4 instances of Fabio running because I have 4 client nodes. And if I click on the details page, the details page for Fabio, we can see that it created, allocations is just the term that we use for one instance of a specific task that you're running in Nomad. So we have 4 allocations and each one is running on a different client node. You can see that they all have different client IDs here. So that's it, our load balancer is deployed. Now if we refresh this, we should get a 404 at this point because sure, now the traffic ingress goes from our ELB to our load balancer, but the load balancer doesn't have any routes yet because we don't have our web app. So we'll do that next. Going back to my CLI. So I'll show you the source code for this web app. It's nothing fancy. It's just a single page Go app for demo purposes. It's like a hello world web app. So it's pretty much just going to say hi and then whatever it sees after the path. The important detail is this line right here where we get the port from the environment. So you can configure what kind of the name of the port that, and you can have more than one port. In this case, it's a simple app. It just listens for HTTP connections on one port, and it's getting the name of the value of the port from the environment variable that Nomad will provide it. And then it's just listening on there. That's about it. So let's go ahead and run this. So we do nomad run, hello.nomad. I should also probably show you the job spec before that. But this is the job spec for the Hello World web app that I just deployed in Nomad. So here, again, the type change. I know in Fabio, we used a system job because we wanted one on each node in our cluster. This is just a service node. So with this, Nomad will use bin packing and figure out the best place to place all of these Hello World web app instances. We want a HA, so we don't want just one, so we're asking for 3 instances. And then now we're using a different driver. So this is the exec driver. The exec driver just gives you a very lightweight container. So it actually does chroot and then creates C groups with whatever resource limitations that you provide here in the resource stanza. And then for the exec driver to work, you just need to provide it a binary. So I've uploaded precompiled versions of this Hello World web app onto an S3 bucket, and I'm just providing the source. And then the destination is actually optional. Just to make it easy, I've made the destination name be the same so that as we switch between versions, I just need to change the name of the binary. But that's really all you need to get your job deployed in Nomad. The service stanza is what gives us integration with our service registry, which is console in this case. So this causes Nomad to actually register this application into console with the IP address and port where it ultimately places it. And we also provide a health check here. So we say, this is again like a relatively simple health check. Like there's not a custom URL. We're just hitting the main page of the app. And we're saying, hit it every 10 seconds with a 2-second timeout. The tags are also configurable. So in this case, the tag starts with a word URL prefix because that's what Fabio cares about. So Fabio, instead of just trying to find all services registered in console, this is how Fabio knows, like these are the services that Fabio should be adding to its routing table. So it just looks for services that are registered with the tag that starts with a word URL prefix. And then the second part is like the routes that you want to register. Here I'm just registering /, which is like all traffic. That's about it. Now, let's go back to the UI. So if we go to our jobs page and we go to our Hello World web app, we can see here that Nomad has 3 instances running. You should be able to refresh this, and you can replace this with your name or whatever message you want. And we've basically got our HA web app deployed using Nomad. So this might look pretty simple, like there's just 2 steps and it's done, but you're actually getting quite a lot of features out of the box just by utilizing Nomad. So you've configured your load balancer or your system job using Nomad. And that's helping you, because it integrates with console, that's helping you ingress traffic into whatever instances that we bring up for our Hello World web app. And more importantly, if say any one of those client nodes that Nomad's running on, or like any one of those EC2 machines dies, then Nomad will automatically reschedule it somewhere else. We've also got a basic health check going. So if for whatever reason, if this web app stops responding, then this particular instance, any particular instance that stopped responding will be considered unhealthy. So we've got quite a lot of features just from doing these 2 simple steps. So that's all well and good, but as developers, we all like to make changes, right? Like we're not going to just have one version and have it run forever. So the second part of my demo is going to focus on deployment strategies. So I'm going to show you the job spec again and talk about the update stanza. So the update stanza is what lets you as either as operators or developers control like how you want to do staggered rollouts for your application. So this particular update stanza, it says that max parallel equals 1. So what that means is when Nomad is doing a rolling upgrade, when we want to switch from an older version of a job to a newer version of a job, we only want one new instance spun on the new code spun up. So in our particular case, we started with 3 instances on the old, then it'll stagger to 3 instances on the old and 1 on the new, and then 1 on the old and 2 on the new, and so on until it's done with the deployment. This min healthy time specifies like how long to wait between each staggered rollout. So we want to, after the application becomes healthy, we want to wait at least 15 seconds before we proceed with the next. This is basically to support very common use case where sometimes an app might start up and then it's just starts up and becomes healthy, but that doesn't mean that it stays healthy. Like something else could happen, like maybe it loads a really large file or it does something and then like it's unhealthy again. So this just gives you a way to control like how long should it be healthy before it's considered healthy, and then we can move on to deploying the next. And then the auto revert is pretty cool too. So it's sort of a conservative way to do deployments where you're saying that if you deploy new code and it becomes unhealthy, then this is going to automatically revert to the previous stable version. So that's really it for the update stanza. And like I said, I have pre-compiled binaries, so I'm going to switch to Hello World v2. That source is very similar. It's just going to add some extra text. So let's run this. And then let's go to the UI. So now you can see our UI actually live reloads. So now you can see that there's an active deployment that's running. So it's actually deploying the new binary that I gave it. Now, if you refresh this, this is just the new version. So the one that says you're awesome. So if you keep refreshing, you'll see that it cycles between the new and the old because it's not finished with the deploy yet. So it does the first one, then it waits until your min healthy time, and then it proceeds with the second and so on. So hopefully everybody on the call can go to this URL and see what's happening. But here, this also gives you a view of sort of what's going on. So it's got, it's placed 3, but 2 are healthy. The third one is going to wait until that minimum time before the third one is also complete. And then eventually we should see this like blue section here go away when the deployment is complete. Probably just another couple of seconds. So I don't see the old Hi Preeta anymore. Now it's all Hi Preeta, you're awesome. So, okay, there we go. So it's finished and the blue section disappeared. So we've got, at this point, I've demonstrated that we've done a safe rollout from old code to new code. So at any given time, only one instance of the new code was deployed, and then it waited until that was stable and successful before moving on and then proceeding with the deployment. So that's this particular strategy is commonly known in the industry as a blue-green, sometimes also called red-black strategy. So that's one of the deployment strategies supported by Nomad. However, it's not the only one. Sometimes we make even more riskier changes where we might actually not want to even have the risk of having take down capacity from our 3 running instances, like replace one of those 3 running instances with new code. So in that case, we could use a strategy called as canaries. If you're not familiar with canaries, like really the history of this term comes from ancient times when miners used to put a little canary in a cage, drop it down a mine shaft, and then if there's poisonous gases, when they lift the cage back up, the canary would be dead, and they'd know that they don't need to, it's too risky for humans to go down. So as far as deployments are concerned, when you do canary equals 1, what actually happens is Nomad will create a new instance on the new code, but it doesn't touch any of your old 3 instances. So you'll have 4 instances in this case with 1 running the new code. And then it requires the operator to actually bless or fail the deployment. So that you can take your time. You could have the canary running for days if it's a really risky change. Wait and watch and make sure all your metrics look right, and then go ahead and bless the deployment. So I'm going to switch to V3. Oops. So V3 is very similar to V2, except that we made the font color green. That's about it. And then we'll go back to the UI here. So now you can see that the UI changed again. It live reloaded between me switching tabs. Now it says the deployment is running but requires promotion. So it's in a to be blessed state. So it's up to the operator to decide whether they want to deploy or not. Now this is a bug we're working on, like the canary is 0 out of 1. This should say 1 out of 1, but really this is the number to watch. 1 placed. And if we go here, it changed from 3 running to 4 running. So it's actually running the canary. So again, if you refresh the page, you should see one of them in a green. Roughly 25% of traffic should go to the canary. So there's the green font. And yeah, so this is basically a canary. Now, as an operator, I've decided that the green color doesn't look good. I want to revert. Now, remember that my job spec actually had auto revert equals true. So all that we would need to do as an operator is to mark the deployment as failed. We can use the CLI to figure out what the ID of the deployment is. So if I do nomad job status hello, I can see here that this is the ID of the deployment, and I'll say nomad deployment fail 9F. Like that, and then we'll go back to the browser. So it's back to 3 running. So it's already reverted my canary. So no traffic should be going to the canary anymore. The canary instance has been killed. So if we refresh this page, you don't see the green thing anymore. And if we go to the versions tab in the UI, you can actually see how the job progressed through all these versions. We actually show a diff here. So that way, anybody looking at the UI can have a holistic view of like what exactly changed between each version. So here's where we changed from V1 to V2. Then here's where we changed from V2 to V3. That was our canary. And then here is where we did the auto revert. So version numbers are always strictly incrementing. But version 3 is basically the same as version 2, or version 1, actually, not version 2. V2, hello V2, which is version number 1. So version 3 is where we reverted from hello V3 to hello V2. Yeah, so that's it for the demo portion. The only other thing that I wanted to share was that we have more, there's a lot more features to additional deployment features in Nomad. We support a gated rollout via health checks, like the health check example I showed. You could make the health checks a lot more sophisticated. We can register separate tags for canaries. This is a feature coming in 0.8.4, which we're probably going to release in the next week or so. So there, for example, you can configure your canaries to always register with a special word like canary or my canary or whatever. And then you can have a standing rule in your load balancer layer that always only sends 0.01% of traffic to the canary. So it gives you like more fine-grained traffic shaping. That way you're not equally distributing across both canaries and non-canaries. There's a concept of a healthy deadline. So that requires applications to become healthy before a deadline. So we don't just wait forever for the application to become healthy. And then the min healthy time is like how long it needs to stay healthy before it proceeds to the next. There are several additional features, and I've linked to our update stanza as well as documentation on various update strategies in Nomad. That was it. I'm going to stop sharing my screen.
Cool. Thanks, Preetha. I'll claim the host. I'm just going to make next. I think next up we have Arul from SAP Ariba. By the way, we'll post all the slides up. We'll post all the slides up right after the call and generate like a PDF and just share that out. And then so everyone should have it. I'll just make Arul the host here. 1 second. All right, you should have control, Arul.
Okay. 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 Yeah, thanks for giving us an opportunity to talk to the community. I'm Arul Francis. I have John Mitchell and like the rest of the SAP Ariba team here today. So this is actually we don't have a demo to show, but then we just want to share how we use it in production. Some stats to share. Little bit about the company. SAP Ariba is part of the SAP family. We provide cloud-based procurement solution. We also operate SAP Ariba Network, which is the world's biggest business network connecting buyers with suppliers. A very high-level overview of our Nomad usage. So we started deploying Nomad in production since June 2016. So it's almost 2 years in production for us on Nomad and a few more Hashi tools like Console and Vault. We have dev environments today running on AWS, Azure, and GCP, all three clouds. And there's some historic reason why we are on all three. But we could get Nomad clusters running successfully on these platforms. And for our production, we are running on multiple bare metal data centers globally, like our own data centers globally. Overall, now we have 200 plus production nodes which is managed by Nomad. We are running on the enterprise version. We recently switched to the enterprise version. We are on 0.7.1 version. We have Nomad ACLs also enabled. Initially, we didn't have it, and then we switched to ACLs recently. We enabled ACLs recently. A little bit on our usage pattern, like what kind of jobs do we run on Nomad? Mostly Docker containers, plus some non-container tasks as well. That's one of the things that we like about Nomad, the ability to run pretty much anything that you want to run. And Ariba apps are primarily Java Spring Boot apps with some Node and some Go apps at this point of time. And we are running a bunch of infrastructure services. That's one thing that we've been constantly adding and working on. We're running Nginx. We're running a Kafka cluster as container on Nomad, orchestrated by Nomad, Zookeeper, Redis, Solar Cloud, Storm, Cassandra, and Kong. And these are all, except for that Nginx, everything else is clustered. So the orchestration is very important on how the cluster is brought up. And when a node dies, like how is that node taken out of the cluster, etc. So the orchestration is very important. We could do all of that through Nomad. Why Nomad? I mean, this is a question that we get actually even internally within the company a lot. So important thing is it's very agnostic. We can schedule containers and non-container tasks the same way. The pipeline that we have built works very well. Like we don't have to make any change whether our end task is container or non-container. It's standalone, but also it has good integration with the rest of the Hashi tools. Example, Console and Vault. It's simple to install and operate, and it's pretty fast with respect to scheduling. Yeah, so that's actually pretty much about Nomad, but I just want to take a little bit of, take like 2 more minutes to talk about our overall pipeline, our CI/CD pipeline, like what are the tools we use and how is it all put together. So we use Vagrant. That's our standard recommended dev environment for developers to work on. The way we have set it up, our production data center, or how things are running in production, everything works in Vagrant. Our standard Vagrant box has Console and Nomad and Vault and Docker installed and then ready to go. So a developer can actually test his app exactly like how it's going to run in production. We use GitHub. We use Jenkins as our pipeline system. We use Artifactory as our Docker registry. We have Artifactory in all our production data centers that manages the replication of Docker layers. We use Terraform for all our cloud provisioning. For bare metal, of course, we have methods to do it. Then, of course, Nomad and Vault and Console, that forms the core of our data center. Docker for all our Docker loads. The Splunk and Elk also for our log management. Datadog for our monitoring. Cisco Contiv for our overlay networking on top of Docker. That also integrates with Cisco ACI in our bare metal data centers, and Packer for building all our cloud host images. Yeah, so that's really the tool set. I mean, I haven't described the pipeline, how it's put together, but then it's pretty much Jenkins. We use Jenkins files, so any change in GitHub triggers pipeline on Jenkins. It goes through various stages. It builds, deploys to a dev cluster. We do the testing there. Then Jenkins basically waits for an approval from the product owner, and when he approves, then that particular build gets promoted and it's available for production deployments. Then we have a Jenkins running in production data centers that's used by our operators to deploy in production. Yeah, I mean, that's like at a very high level, that's what we do. Yeah, I mean, that's pretty much what I have in my presentation. Yeah, I mean, if there are any quick questions, we are happy to take that, or like over to you, Anubhav.
Thanks, Earl. I really appreciate it. Thanks all the presenters, Alex, Preeta, and the Nomad team, and Arul for taking some time and doing this with us. So we have a lot of questions, and I think we have like around 15 minutes. So what we'll do is like the questions that we aren't able to answer, we'll write a detailed response on the working document. So you can leave your email if you want us to email you with the question. Otherwise, you can just work on it. If you don't want to leave your email, that's fine. You can just look at the answer just below the question. So we'll go through them and answer them. So I think Shantanu just asked, what about the scale at SAP? So I'll take some from the chat and then randomize it and take some from the working documents as well. So Arul, there's a question about the scale of SAP. So I'm not sure. Shantanu, do you mind clarifying the question? Oh, okay. How many nodes, VMs, and how many Docker? He basically wants the numbers.
Yeah. So nodes, we have about 200 nodes overall in production, bare metal nodes. There are no VMs in production, but then how many Docker containers? I don't really have a number. Thousands? On an average, it takes 4 or 5. So yeah, I mean, in all data centers put together, more than 1,000 containers. Yeah, overall. And then we also do, we do the blue-green deployment slightly differently. We deploy a new set and then we switch traffic. So at times it's more than 1,000. It goes up and down. So yeah.
Okay, thank you. I think just to clarify, I think you said thousands. That's what I heard. Thousands.
That's right. Yeah.
Okay, sounds good. On the discussion questions, I'll take the first one. What are the major features planned for Nomad 09? Anyone from the Nomad team can answer this?
Yeah, sure, I can answer this. So we have a few features for 09. Some of the interesting ones will be drivers as external plugins, and it'll become an interface where people can implement them out of band from Nomad. So you'll be able to create whatever driver you want and use it with Nomad without having to fork Nomad. So that's one interesting one. Another is device manager plugins, and they'll enable things like GPUs and potentially FPGAs and tensor processing units, for example. We'll also be working on affinities and anti-affinities and spread. So you'll have control of that stuff via your job spec. Let's see. Yeah, I think those are the major ones off the top of my head.
Cool. Thanks, Alex. So I'll just skip the next one. A Nomad introduction, production use cases. I'll skip that one. We'll talk about, are there any scaling recommendations for the number of nodes per cluster? There's a hint that we have problems doing this for 15K nodes per region. Who's this person?
Yeah, it would be awesome if you could either file it. Well, okay, yeah, I guess my recommendation would be file an issue with us because Nomad should support that amount, so we can help whoever that is. Obviously, it's anonymous on this, so we can't reach out to you. But yeah, I think there are a couple things you want to take into consideration when deciding whether to deploy more nodes in a region or to split it off into a different region. So within a region, you have one failure domain with your schedulers. So if you lose quorum, you now have, you do not have your orchestration layer running, and it can't continue to make placement decisions. But within this failure domain, you can have workload fail between nodes there. So that's the approach of regions. When you federate, you can have workloads be submitted from one region into another, but they won't cross over. So you have redundancy, you have separate failure domains when you federate regions. Generally, you probably don't want more than like 10 to 20,000 in a single region, unless you're at a surprisingly large scale. But yeah, I wonder if that answers your question. If not, we can talk more.
So I think someone just like sidestepped the process and just inserted this thing in there. I think this is related to what you answered, Alex. Is talking about AWS region and Nomad regions, and like sometimes like people get confused. A bit of understanding there. Like what is the difference between a Nomad region versus a AWS region?
Yeah. So generally, Nomad regions can contain many data centers, and you can think about AWS AZs as like a single data center even. So you can have multiple AZs in a single Nomad region. And you want your Nomad servers to be distributed among different AZs, so you have some redundancy there. But you generally want them co-located such that they have low network latency, so you can maintain reliable quorum and have high throughput. So you'll generally co-locate your Nomad servers, which form your region, inside closely in co-located data centers. So yeah, there's a lot of terminology. There's AWS's regions, AZs, Console has data centers. So it is a bit confusing.
There's another quick follow-up question from the same person, I think. What is the low latency? What does that mean? Does it mean like under millisecond, I don't know, 10 millisecond or 100 millisecond?
Yeah, you can see it. We have under our docs some of the networking requirements when creating clusters. Your Nomad servers should have sub 10 millisecond latency. Your Nomad servers and clients can have a much larger latency than that since they use heartbeat mechanism. So you can potentially even have up to a second or two latency between the servers and clients, but that's obviously the lower latency, the better.
Cool, sounds good. So I think we'll just add the links there to that question from our docs into the working document. So I think there's a question from Chris.
Mishra, I guess before we move on, I'd just like to reiterate, whoever that is, feel free to file any issue with details so we can help you unblock past that.
Cool. So Chris, there's a question from Chris with respect to rolling restarts, replacement of jobs. In what order is that performed? Is there an existing allocation that stopped and then a new allocation started?
I can take that one. So it does. So for rolling updates, it does them in place. So the existing one is stopped and the new one is started kind of in the same transaction, if that makes sense. In practice, because the actual work is done on the client nodes, like the server tells the client to stop the old one and start the new one somewhere else. So you can't really like time align it. It could be one before the other, if that makes sense.
Cool, thanks, Preeta. Okay, we'll take one from the document. It's getting longer and longer now. I think we should have folks like actually maybe add the email, or like some kind of information so we can, kind of respond back, or you can file an issue or actually mail, create like a new topic in the mailing list if you want, and we can respond there as well if you want. We'll respond in this document for sure, but like just to reiterate that you have all those other avenues to kind of get in touch with the Nomad team. So there's another question about, are there any plans for, having more tightly, like the console integration with Nomad, basically. So example, tying in the service metadata, enabling tag overrides and stuff moving forward.
Yeah, so I guess that kind of goes to the details of how HashiCorp operates. We have separate teams that are all building and releasing on separate timelines, but we do always like to maintain our integrations and keep them up to date. So as new features come out, depending on where each tool might be in its release cycle, there might be a lag of getting that feature set into Nomad or console, vice versa. But yeah, we generally, where appropriate, we want the integrations to be fully featured. So if we ever miss something, or you feel like it's been too long since it's been out in one or the other, feel free to file a Nomad issue.
Sounds good. Okay, so the next question is there any reason why variable interpolation doesn't work for the constrained values?
Yeah, I can take this one as well. So Nomad has interpolation that currently only exists on the client. So this interpolation is very useful for injecting environment variables or things into your task arguments that are specific to the node. For example, what's the IP that's been assigned to my task? What's my vault token, etc. That they materialize at runtime. They don't necessarily exist prior to an allocation being created and scheduled. So that was the motivation for the current version of interpolation we have existing only on the client. Long term, and I guess if the intuitive leap didn't make sense, the server has to determine, constraints are a scheduling time dependency. So all the potential information has to be materialized at scheduling time. So unlike the client, it doesn't interpolate, it forces it to be fully materialized. And so our long-term plans of supporting this and a larger set of community requests for variable interpolation throughout the job file will likely be to support the next version of HIL, which is HashiCorp's, or HCL2, which is HashiCorp's configuration language. And that version is currently being first deployed on Terraform as we speak, and then we'll bring the learnings and library to Nomad and hopefully be able to have full job interpolation. And then you will be able to interpolate in the constraint stanza. But this is a few months out.
Cool. Sounds good. Okay, the next one is, I knew this one of these questions are going to come on. Is there anyone using Nomad to deploy VMs that are themselves Nomad agents?
Maybe we open it up to the community. Not that I know of, but there's really no reason that's not possible.
Is someone doing that on the call? Can take over? Okay, someone is. I think Shantanu is. Okay, cool. The next one is, which one is this? Yeah, any plans for supporting CPU sets, like CPU, socket pinning for Docker and for other exec driver?
Yeah, so currently we use CPU shares to define how CPU is enforced. Some workloads can benefit by pinning onto particular CPUs. There's cache coherency reasons, etc. I guess for for the majority of applications, this isn't the lowest hanging fruit for them. So other features the Nomad core team has been working on has hopefully been more impactful for people. But down the line, yeah, it would be very cool to be able to have a part of the Nomad client to be monitoring the workload needs of what's on the machine and pinning to specific CPUs, or via the job spec to allow job operators to say, I require the entire CPU, or I require certain CPUs, rather than just specifying shares. So I guess the short answer is yes, but it hasn't been the highest priority yet.
Cool. I think I'm going to skip a few of these questions to go to Errol's question, because I think he's only present for this call, and then we can answer all these other questions ad hoc, since we only have like a few minutes left here. So Errol, this question's for you. Any level of detail about Kafka broker persistence would be appreciated. Also, any level of details on running Solaris Cloud and Nomad, any blog posts that you can link them. And then Errol, maybe you can add them here, or you can talk about it right now.
Yeah, so I don't have a blog post to share, but I can I can figure out a way to share some notes on that, maybe offline. Anubhav, I can try to share it through you. About Kafka, we are ready to run Kafka in production. We're very close to run it in production. Right now, it's still in our dev. So right now, still the thought process is Kafka will take care of the replication within the cluster. That's really the thought process at this point of time. But we have a dedicated platform team working on that, like testing the resiliency and failure modes and all of that. One thing that we are doing with Kafka is we are going to run it on dedicated host for now. That's like based on recommendation from the Kafka community and from Confluent. So we will, we did something with the Nomad class and Nomad targeted deployment. So we have a set of Kafka set of servers dedicated just for Kafka. They have the node class set with a particular tag called Kafka. So the job will deploy only to those machines, and we're going to deploy like only one broker per host at this point of time. Even though it's going to run as container, it's going to run on just one host. So that's really what we've been doing on Kafka. Yeah, and Solar Cloud pretty much follows the same methodology. Yeah, and most of these clusters, the thought process at this point of time is data loss. Like if you lose a node, the Solar cluster will take care of the data replications. So that's the thought process.
Cool. Thanks, Errol. So what we'll do is, I think this is the hour mark. We'll try to be a little bit more disciplined and cut it at the hour mark. But we'll for sure answer all the questions that folks have in the document. If you want to leave your email, please do so. And then Errol will share some details with me that he's talked about, and I can share that with the community as well. I really appreciate everyone attending the call. This is the first time we're doing it, so we're going to hopefully learn a lot and try to do a better job at organizing the call next time. I hope this one was entertaining for you. Yeah, so thanks for everyone for attending. Thanks for all the presenters, especially Errol from SAP Ariba. We'll make the slides available as soon as possible. We'll also make sure that the next one is announced. The next call is announced as soon as possible as well. So again, thanks for attending and have a great day, everyone.
Thanks. Thank you.
Thank you.